Yes, in yesterday, Pate, we were learning about the integration. The fact where we have to understand is today our topic is to learn about integration by parts. Just 1 second. Yeah, integration by parts. Yes. Then, if you are referring to integration by parts, we have to see with under which circumstances we have to use this integration by parts. Pate. For example, I think if you are just refer with the yesterday notes as well. So when I'm just explaining the concept of integration by substitution, it comes under this situation. But suppose that integration of some kind of function to the power n is there, and its differentiation outside or some kind of a constant times of integration outside straightforward, you can write it's k times of fx to the power n plus 1 over n plus 1 plus c. For example, if you want to integrate x squared plus 2x plus 3 times of 2x plus 2. So simply here the differentiation is available here. So you can say this is to the power 4 or something. So you can write this is x squared plus 2x plus 3 to the power 5 over 5 plus c. For some kind of constant time, we want the same thing. But if this differentiation is not available here, what is supposed to do? For example, x squared plus 2x plus 3 and yeah, to the power 4. If this is just like this, that's one also you can find it with the x plus 1 or not. So here even you can do it. So what you need to do is you can put a half outside. We did one similar questions with this x squared plus 2x plus 3 times of to the power 4, and you can make 2 here, 2x plus 2. Then you get the answer over here as 1 over 2 x squared plus 2x plus 3 to the power 5 over 5 plus c. You can write it because if it is like a, you can multiply by just a single constant. If you can form the differential format of it, you can get this answer. But under this situation, we are helpless. So just like this, x squared plus 2x plus 3 to the power 4, and this is suppose that if it is 2x minus 3. So just multiplying this one just from a single constant, you cannot for the differentiation. The differentiation over here is 2x plus 2, sorry, 2x plus 2. So you cannot make 2x plus 2 by multiplying this one by just a single constant. So that is not possible in such situations. These theories, the theory what you have learned over here is not applicable. In that situation, that means I have just to make a brief in the last session even. If it is a function fx to the power n and the differentiation is not here, here it's gx, that means this is gx, where gx is not equals to f dash x, okay, times of f dash x, whatever. So in that situation, today we are using two approaches. The first one is integration by substitution. Integration by substitution. That is what you have learned yesterday, Pate. Then the other part is, Pate, integration by parts. Now, how do you filter out whether to use integration by substitution or integration by parts? The simple idea, this is not a rule actually, but just a clue to understand the situation. Suppose that if this is fx, the function is fx to the power n and gx, then if fx and gx are same type, then you can go by integration by substitution. Integration by substitution, right? For example, just like this, sine to the power 4x tan x. So this is the same type, right? For example, e to the power 6x plus 4, and this is just like e to the power 3x or something. So this is the same type, right? If it is just like x squared plus 4x, the square root of it times of 6x. So this is the same type. So in that situation, you can go by integration by substitution. But if it is this situation, just like if these functions are not in the same type, fx to the power n and gx, but fx and gx are not same type, not same type. For example, integration of x e to the power x, integration of sine x e to the power x, integration of ln x into x. Those situations, so you have to go ahead with integration by parts, integration by parts, IBP. So you can go ahead with this. That's a simplest variation of understanding how to go ahead with integration by substitution, integration by parts. So this is the simplest way of identifying that fact. So we'll go ahead with certain question and see whether how to do that kind of question, right? So we'll start with the first example. So what is the base for this integration by parts, right? So we are learning about IBP, integration by parts. Yeah. So the basic over here is we know that if you differentiate, this is a theory for that. If you differentiate u into v, that is the you can use the product rule. Keep u and differentiate of v. Sorry. dv by dx plus keep v and differentiate u, du by dx, right? Okay. So if you I'll subject this part of it with it. I'll just subject this part. U dv by dx is equals to d by dx of uv minus v du by dx. That is the base, right? Okay. Du by dx, sorry, this is du by dx, right? Then I'll integrate the both sides. U dv by dx is equals to integration of d by dx of uv minus integration of v du by dx, right? Okay. Then what you need to do get here is, then we know that this total function is differentiated and integrated. Therefore, you can cancel those extents. So you can cancel this differentiation and integration at once, because you know that it's not cancelling, actually you are doing the forward function and you are doing its reverse. So integration formula for this one, integration by parts, is u dv by dx is equals to uv minus integration by v du by dx, right? Okay. Then this is the formula, right? Okay. Let's go ahead with that. This is the formula. Right. Okay. Yes. Then let's see from a question how to understand this kind of situation, how to apply this integration by parts, right? For example, you get a function somewhere like this, x e to the power x. Now to apply to this formula, we have to filter what is u and what is dv by dx. That part we should know clearly. This is the sequence we follow up to understand what is u and what is v. Already we can use filtration of u. How to identify u? How to find u in integration by parts, IBP. That's a point. So this is a way of doing it, but there's a rule. The first rule is uh, if there is a ln function, If there is a long function, use as u. So first priority gives with if there is a long function for the long functions, long functions. Second one, the second priority gives for the function which simplify at differentiation. So if a function simplify at differentiation, we give next priority to that kind of functions. Yes, the third one. Third one is functions which converts at differentiation. From question, let's try to understand how do you verify with this. For example, let's go ahead with first example and try to make it. Okay. Yes. Yes. If you use this equation, right? Okay. Right. Suppose that you get integration by x ln x, right, dx. Dx is the integration variable. So according to this priority, the first priority comes to, there are two functions, x and ln x. So which one comes as u, Pute? The first priority for u is for the ln function. So there is a ln function. So there I just define u. I just define u as ln x according to the rule what we have learned, ln x. With that, you need to find what is du by dx. Ln x, what is the differentiation of ln x? Is 1 over x. Then we will consider dv by dx as the rest of the function, that is x. So I just consider this one as u and this part as v. Therefore, we need to find what is v. V. What is v? D, if the differentiation is x, means v become x squared over 2, right? Okay. Then we can use the formula. What is the formula? Formula is uv minus integration by v du by dx, right? Okay. Then we'll put it. U is ln x, v is x squared over 2 minus integration by v is x squared over 2 du by dx. Du by dx is how much? Du by dx is 1 over x, right? Then this simplifies into x squared, or remember you cannot multiply, this is just a ln x squared ln x minus this is integration of x squared and x cancels x over 2, right? Okay. Then if you do the integration, you will realize that the answer become x squared over 2 ln x minus x over 2 integration is x squared over 4 plus c is the final answer for this. So if it is a finite integration, you can substitute the figures and you can obtain this answer. That's a way of doing this kind of question. So this is the final part of this one. So that is a way of doing this kind of a question, right? Okay. Right. Then let's go to another question and let's try to make it. I'll just use a different color. Then I can use the other side of the page. Right. Okay. Then let's go ahead with this. Right. Yeah. Then Pate. Right. Yeah. Then if it is a situation somewhere like this, Pate, we'll go to the next example. The second example is if it is integration of x e to the power x dx. So what can you understand? Now there is a function, we need to, we have to define what is u and what is dv by dx. According to this priority, the first priority go to the ln function. Ln, first priority goes to ln. So is there any ln functions? No, here there is no ln function. Second priority goes to the functions which simplify a differentiation. So you can say, if you get ex as u, if you differentiate it again, you get ex. It's not simplified. But if you use x as u, at the simplifies as the differentiation. That is what you mean by simplify as differentiation. So what is that answer? It's turned up to 1. We will get dv by dx as ex. Therefore, v is the integration of e to the power x is e to the power x. Then you can use the formula, right? I'm not writing the formula again and again because it's a formula. It's, you can write uv. U is x, v is e to the power x minus integration by v du by dx. Du by dx is 1 to the right. Then you can say this is x e to the power x minus e to the power x integration is e to the power x itself. So the answer is this. So that is the way of doing this question. Okay. Let's go to another question and see. Right. Yes. The question, this is the question, this is the example. I'll label this one as example 1. This is the first one, and this is the second one. And let's go a little bit further, and I can work out another question over here. X is function. Therefore, you can say this is integration of this way. So it just comes with like this x to the power 2 sine x. Yeah, or other than that, initially we'll work out with this one, but I just make without the powers. I just initially just work out with just x. Okay. Yeah. So here we need to define what is u and what is dv by dx. U is what you can say. Here there are two functions. If you use sine x as u, the differentiation is cos x. It goes to a conversion. It goes to a conversion, but it's not a simplification. That is the third priority. If you use u as x, at the differentiation, it simplifies. So it's pretty simple. You can use this one as u. So du by dx it become 1. It's sine x. What is the, then v is the integration of sine x is minus cos x. Right. Then you can use in the formula uv. U is x, v is minus x cos, sorry, there's no x, minus cos x, minus integration by v minus cos x du by dx. Du by dx is 1 dx. Right. Okay. Then this is turned up to minus x cos x, this minus and this minus turn up to plus integration of cos x. So it is minus x cos x plus cos x integration is turned up to sin x plus c is the next answer for that. That's a way of doing this kind of question, right? Okay. Now, let's move up to the fourth question. That is a little bit of a contradictory, where to define, how to define this value for this, right? Okay. The function is put e to the power x sin x, right? Okay. Now, when you get this put there, how do we define u and how do we define dv by dx, right? Okay. Now let's go to the priority order. U and the rest of the turn up into dv by dx, right? Okay. If I select ex as u, the differentiation is e to the power x. It's not simplified or it's not converted. But if I use u as sin x, the differentiation is what? It cos x. It converts into another function. Therefore, you can use the third priority fact, u as sin x. So therefore, turn up to du by dx become differentiation of du by dx is cos x. Cos x. And dv by dx is e to the power x. Therefore, v become e to the power x itself, right? Okay. Now, this is a little bit of a lengthy question. Let's see how to do this. Then you can use the formula uv. U is sin x, v is e to the power x minus integration by v du by dx. Du by dx is cos x, right? Okay. Then you can say e to the power x sin x minus, now again there's a problem. Now for this case, it's not integratable. So again, what we need to do is for this part, again, we need to do the integration by parts. That is a practical situation, right? Okay. Then I'll label this one as I. That's easier for me to do this. Then I'll consider u as again the same condition with it. Cos x. That is, then you can say du by dx become minus sin x with it. Right. Then we can say dv by dx is equals to e to the power x. Therefore, we become e to the power x, right? Then you can say I is equals to e to the power x sin x minus, again, for this part, you can use the integration bar. by parts, right? Okay. U is cos x e to the power cos x e to the power x minus v du by dx is sin x minus sin x, right? Then if you simplify this, you can turn up to I is equals to e to the power x sin x minus e to the power x cos x minus minus plus into minus is again minus integration of e to the power x sin x. Then how can you do this question? Now you can understand that from the beginning, this is e to the power x is I. We just define this way. That's why I asked you to define it as I, right? Then instead of this part, again I can write this one as I. Then you can say I is equals to e to the power x, if I take it out, sin x minus cos x minus I. Then I can bring this I to other side, turn up to 2i. 2i is equals to e to the power x, e to the power x, that is then sin x minus cos x, right? Then with that you can say I is equals to e to the power x divided by 2 sin x minus cos x would be the final answer for that. That's a way of doing this kind of situation. Sometimes you need to apply integration by parts for more than one times to get the final answer. This is a way of doing this kind of a question, right? Okay, let's go to another question. Right. Then, if it is integration of x squared sin x, again we have the same problem. We need to define which term is u and which term is v. So simple idea is you can easily define u as x squared. Therefore, you can write du by dx is 2x. Then dv by dx is equals to sin x. Therefore, we become integration of sin x is minus cos x. Therefore, you can write uv x squared into minus cos x minus integration by v, that is 2x. 2x. Then this is turned up to minus x squared cos x. This minus and this minus you can make it as a plus integration of 2x cos x. Now again there's a problem. This is not an integratable. So again you have to use the integration by parts for this part, this section, right? So you can say u equals to 2x and du by dx become 2. dv by dx is equals to cos x and v is equals to integration of cos x is the sin x. Therefore, you can write minus x squared cos x plus u is 2x, v is sin x minus integration of v du by dx. Sin x du by dx is 2, right? Okay. Then you can work out minus x squared cos x plus 2x sin x minus 2. Sin x integration is minus cos x plus c. So you can write the final answer minus x squared cos x plus 2x sin x plus 2 cos x plus c is a final answer for this. That's a way of doing that kind of a question. Yes. Let's go ahead with another part of it. If it comes to a question somewhere like this. This is some kind of a standard integration format where we have to prove it from integration by parts. That is the integration of ln x. If you happen to see a question like this, we just take it like this. We'll take 1 times of ln x. That's a way of doing this question. Ln x dx. This is x, right? Then we will consider u as ln x. Therefore, du by dx become 1 over x. Then dv by dx is equals to 1. Therefore, v become x to the right. Okay. Then if you use this formula, you can say uv. U is ln x v. V is x minus integration by v x du by dx 1 over x. So this is turned up to x ln x minus integration of 1. So that is turned up to x ln x minus x is the final answer for that. That's a way of doing this question. Right. Then this question today. Integration of ln x whole thing square. This is the other standard formula where we should know. Again, we use the same technique. We use this one as 1. This is ln x whole thing square. Right. Then we will consider u as ln x whole thing squared. Therefore, du by dx become ln x whole thing squared. Differentiation is 2 times of ln x to the power 2 minus 1 is 1 into differentiation of ln x. That's a power rule. Ln x. So this is turned up to 2 ln x. Differentiation of ln x is 1 over x. Right. Okay. Then we can say v. dv by dx. dv by dx is 1. Therefore, v become x. Right. So if you use this formula, uv, u is ln x whole thing squared into v. V is x minus integration by v x differentiation of this 2 ln x over x, then dx. Right. Then this x cancels with this x. Final turn up into x ln x whole thing squared minus integration of 2 ln x. Then you can understand that ln x integration we already known from here. So again, you can do the integration by second times, or you can use the above format for that. So this is turned up to, so you can say this answer is x ln x whole thing squared. Actually, this is squared, come for the whole thing, minus 2 ln x. Ln x answer we already known from the first part of it. X ln x minus x. That's the answer for that. Okay. So with that, you can say this is, it comes to x ln x whole thing squared minus 2x ln x plus 2x plus is the final answer for this. That's a way of doing this kind of a question. Right. Okay. So all these questions in this exercise are the same format. So we need to follow up some additional substances are there that to different integrate. So you can use this. Yeah, these are the ways where we were doing. This is the fractions we are doing this example. So this is the same kind of questions they expect us to do in this kind of situation. So you need to work out this kind of questions, and if you just work out a question somewhere like this, I didn't do this kind of situation, some similar question similar to this, right? That is integration of 6x squared 2x plus 1 to the power 3. So in this kind of situation, anyway, you can use anything as u, but I preferably the term with less number of terms for considering u is much easier. So it is, then you can write du by dx is equals to 12x. Then we can get dv by dx equals to 2x plus 1 to the power 3. If you integrate it, you get the answer 1 over 2. 2x plus 1 to the power 3 plus 1 is 4 over 4. That is 1 over 8. 2x plus 1 to the power 4. Right. Okay. Then you can write the answer uv. U is 6x squared. V is 1 over 8. 2x plus 1 to the power 4 minus uv minus integration of v 1 over 8. Sorry, I think I made a mistake over here. This is wrong. Yeah, so this is not integration. This is wrong. So we consider dv by dx as equals to 2x plus 1 to the power 3. Ah, yeah, no, that's correct. Ne? So if you just get v, v is the integration of that. The integration of that is 1 over 2 times of 2x plus 1 to the power 4 over 4. Therefore, it's turned up to 1 over 8, 2x plus 1 to the power 4. Right? Okay. Then let's go ahead with this. Then you can say u 6x squared into dv by dx. Sorry, v is 1 over 8, 2x plus 1 to the power 4 minus integration of v 2x plus 1 to the power 4 du by dx. Du by dx become 2x. 2x. Then this is turned up to 6 over 8 is 3 over 4 x squared 2x plus 1 to the power 4 minus 2 and 8 it cancels 1 over 4 integration of x 2x plus 1 to the power 4 dx. Again, what you can do here is here the differentiation of this is not available here. Again, you can use uv formula for that. I'll consider u as x. Therefore, du by dx become 1. dv by dx equals to 2x plus 1 to the power 4. Therefore, this is turned up to 1 over 2, 2x plus 1 to the power 5 over 5 plus c, right? Sorry, not c. C is not enough to c. C comes at the end, right? Okay. Then you can write the final answer 3 over 4 x to the power 2, 2x plus 1 to the power 4 minus 1 over 4 times of uv. U is x into, this is 1 over 10, 2x plus 1 to the power 5, simplification of this, minus integration of v, 1 over 10, 2x plus 1 to the power 3 du by dx. Du by dx is 1 to take, right? Then it's pretty simple. So you can say this is 3 over 4 x squared 2x plus 1 to the power 4 minus, if you simplify this, put x over 40 2x plus 1 to the power 5 minus, here 1 minus 1 over 4 into minus is plus 1 over 4. This one with this integration of, you can take 10 out even, then you can make 40 2x plus 1 to the power 3. Then you can write the final answer 3 over 4 x squared 2x plus 1 to the power 4 minus x over 40 2x plus 1 to the power 5 minus 1 over 40 times of 1 over 3, sorry, 1 over 2, 2x plus 1 to the power 4 over 4. Okay. With that, you can write the final answer. Final answer is this 3 over 4 x squared 2x plus 1 to the power 4 minus x over 40 2x plus 1 to the power 5 minus 40 into 8 1 over 320 2x plus 1 to the power 4 plus is the final answer for this. That's the way of getting this answer. Yeah, right. So that is a way of understanding this kind of a question.